In this example, we're going to determine the value given the area under a normal curve. So a manufacturer knows that their items have a normally distributed lifespan with a mean of 4.2 years and a standard deviation of 1.4 years. The 5% of items with the shortest lifespan will last less than how many years? And give your answer to one decimal place. So let's go ahead and highlight a couple of things. Knowing that we have a normally distributed lifespan, we know the distribution, right? And we know the mean will be 4.2 and the standard deviation of 1.4 years. So the first thing I want to do is go ahead and draw a figure. So if I went ahead and drew a figure, the highest peak of the curve is the mean, which is 4.2. Let me go ahead and add and subtract the standard deviation, 3 to the left and 3 to the right. So if I go to the right, I'm going to have 5.6, 7, and then 8.4. And then to the left, 2.8, and then 1.4, and then 0. Okay, so then 5% of the items with the shortest lifespan will last than how many years? So we're looking for a couple of things here. We're looking for 5% and less than how many years will last less than. So here, maybe right here, let me draw maybe right here, will be some C value, and then the area will be in the left tail because it's less than, and it's 5%. If it's 5% and less than, then I do know it's a tail, right? And it'll be on the left side. And I assume that it will be between 1.4 and 2.8. Okay. So now the second part would be to decipher what we're going to do. So if I'm given area, so let me go ahead and, right, this is 5%. So let me write this out. So the probability that X will be less than some C value equal to 5%, or in other words, 0.05. So this implies that C is going to be equal to the INV norm, in which we get area to the left, 0.05, comma, the mean of 4.2, standard deviation of 1.4, and then we'll select left on the calculator, or in other calculators we could just select, have the area to the left. I'm going to use Desmos. So in Desmos, we go ahead and go to the distribution and hit normal distribution, and we'll put the mean and standard deviation, which was in our case 4.2 and 1.4, comma, 1.4, close it, and then hit a dot, go back to function, and go to intersect CDF, and then we'll put the area to the left, which was 5%. So we have 1.89 blah, 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 blah. So if we round to the nearest one decimal, it'll be 1.9. So this means that the 5% of items with the shortest lifespan will last less than 1.9 years.